Hi everyone, welcome in this first video of the serial under the name of Energy Efficiency Tip of the Day. In each video we'll take one specific problem that is causing loss of energy or loss of energy efficiency, and we will see how we can mitigate this problem and what could be the action that we can do in order to solve it. Today we have one problem, they call it oversized pump problem. We will see what is the reason behind this and what we can do in order to solve it. We will start by the reasons behind the problem. One reason could be the wrong selection for the optimum size. In most of the cases, the target for the designer is to make a good match between the system curve that he has and the selected pump curve in order to put this operation point in the area where the efficiency at the maximum. They call it best efficiency point, and in some cases it is not a specific point, it is more than a region for the best efficiency. So the good designer will make the pump operating at this zone where the pump is working, as we said, at the highest efficiency as possible. If this match came here, the intersection became here or more at this side, it will not going to be the best efficiency zone, and the pump will be running with high energy consumption, which is not required. In other cases, we have seen people making wrong fitting when they are reusing their equipments. For example, if they have application for 50 meter cube per hour and they have already one pump in their store, 100 meter cube per hour, some will say, okay, let's take this pump, use it for this application, and they will have as a way out to decrease the throttling valve opening or using a bypass for the downstream equipment. Both of those actions are waste of energy, and they will have a bad impact, as we will see later on the pump. In some cases, we have seen also another group asking for a good margin or large margin than the one which is the optimum margin should be there for the pump to operate, because they are thinking about retrofitting the plant in the future. But they end up with this project will take more time, so they will end up using a large pump for a small application, and again it is a waste of energy. So as we say, the consequences for this one could be definitely loss of efficiency for long periods of operation, as we can see here from this one, where they have selected pump with not a very perfect selection for the pump curve. Also, as we said, it is a waste of energy. We mentioned something related to maintenance, because using the pump with throttling downstream the valve for the pump, this will have a back pressure on the impeller. This back pressure will cause frequent replacement for the bearing and for the seal, also frequent damage. So again, it is a high operational cost from the maintenance point of view. So what could be the proposed solution used in the industry in this case? Definitely it will be pump downsizing. One option could be impeller trimming, but this kind of solution will work only for 70% reduction from the nameplate capacity for the pump. Also, we can think about using variable speed drive if it is feasible, and if the system that is running downstream the pump is not using high static head. For example, if we have a cooling circuit using water or whatever was the fluid, this application could be there if there is enough margin in the capacity for the pump, and as we said before, there is no constraint from the static head. In other cases also, we can consider using a pony pump arrangement, which is a small pump with a large pump. Small pump will be running most of the time. The large pump will be used if there is a occasional need for larger flows. For example, for the wastewater bonds or the wastewater treatment in most of the plants. Another conformation or another way of configuration could be the identical barrel pumps, here using the larger flow distributed in a number of small pumps, and we add pumps as it is needed from the operation point of view. Again, those two will work, assuming that the downstream piping is working or designed for this additional flow that we are adding whenever we need. So again, to summarize what we have proposed here in terms of action, we need to check our pumping system, find the tuning opportunities, as we said. Then we need to make a list for the pumps that running with a low performance, specifically the large pump that we have in the system. In some cases, they call it significant energy users. Then we need to adjust the pump flow, avoid using the bypass as much as we can. Also, we need to check the feasibility of installing variable speed drive if the operation condition really acquiring this or accepting this. Then we need to compare the pump downsizing other option, like we said, the trimming or other kind of option that we have just described. This was a quick tip related to oversized pumping problem. I hope you find it useful. I will leave a link for a PDF format of this mind map for you, in order you can use it in the future or share it with your colleague to increase our overall energy efficiency awareness. Thank you so much, and I will keep you updated for the next videos related to energy efficiency tip of the day. Thank you. Stay tuned, try to save energy, increase the awareness of the stakeholders, and see you in the next video, inshallah.